everyone, welcome you to General Chemistry tutorials. Today we'll be looking at a question, and the question is: a mass of 350 grams copper pellets at 100 degrees Celsius was mixed with 200 grams of water at 22.4 degrees Celsius. The resultant temperature of the mixture was 33.2 degrees Celsius. What is the specific heat capacity of copper? That of water is 4.184 joule per degree per grams. First of all, let us have a recall of what is specific heat capacity. Specific heat capacity is a physical characteristic or property of a substance, which is the amount of energy required to increase the temperature of one unit substance by 1 degree Celsius. So from the question, we are asked to calculate the specific heat capacity of copper, given that of the specific heat capacity of water. Here is an answer to the questions. Where mass of copper pellets is equal to 350 grams, temperature of copper pellet is equal to 100 degrees Celsius. Mass of water is equal to 200 grams. Temperature of water is equal to 22.4 degrees Celsius. The resultant temperature is equal to 33.2 degrees Celsius. Specific heat capacity of H2O, which is water. The chemical formula for water is H2O. So the specific capacity of H2O is equal to 4.184 joule per degree per grams. These are the data given in the questions. So we can now say let the C subscript P be equal to what? Specific heat capacity of copper. Then the temperature difference, which is what delta T1 stands for copper, delta T2 stands for water. So delta T1, which is for copper, the temperature difference is equal to 100 degrees Celsius minus 33.2 degrees Celsius, which is equal to 66.8 degrees Celsius. Then delta T2 for water is equal to 33.2 minus 22.4, all in bracket, degrees Celsius, is equal to 10.8 degrees Celsius. Recall that heat is equal to mc subscript P delta T. That is a chemical, that is a equations that relate the heat and heat capacity with mass and the temperature. So after mixing, that is, after mixing the copper with water, after mixing, there's going to be a heat lost by copper, and there's going to be what? Heat gain by what? Water during the process. So after mixing, when I first say understand that heat lost by copper must be equal to heat gain by water. Therefore, using the equation above, which says H is equal to mc subscript P delta T, we can now say that heat lost by copper, which is equal to what? 350 times the C subscript P times bracket 66.8 must be equal to the heat gained by water, which is going to be what? 200 grams, 4.184. That is the specific capacity of water times the temperature difference, which is what? 10.8. Therefore, altogether, I have it to be 350 times, all in bracket, times Cp times, all in bracket, 66.8 is equal to 200 bracket 4.184 bracket close bracket 10.8. So making C subscript P the subject of the expressions, we have it to be Cp is equal to 200, all in bracket 4.184, all in bracket 10.8, all in bracket, divide by 350 times 66.8. I will have our specific capacity of copper to be equal to 0.3865 joule per degree per gram. So this is the specific heat capacity of copper, that is the amount of energy required to increase the temperature by what? 0.3865 units of copper by 1 degree Celsius. Thank you very much for watching. Please click on the subscribe buttons to be notified when more chemical related questions are being posted. Thank you.